Hello guys, it's Mr. GoSign here. So we're on day 2 of this lock-in, and we're going to be solving by square rooting. Now we're going to use the same methods that we used yesterday, so you can solve the genome. So we want to find the square root of 27. Now if we try to type in square root of 27 into the calculator, it won't give you a nice number. So we'll try it right now. So I press second square root of 27. And as you can see, we get a decimal because square root of 27 is not a perfect square. So since we're talking about perfect squares, let's write down all the perfect squares. We're going to need that for this problem. So we'll list here perfect squares. Alright. We have 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3, which is 9, and so forth. Alright, I'm just going to keep going. 9, 10, 11, 12. I think that's good enough for now. Alright, so these are your perfect squares that we're going to look at. So 27, we want to break that up into something that has a perfect square, and then it's extra. So I'm going to break this up. I'm going to write my radical signs for these. Beautiful handwriting. Alright, now we want to see what goes into 27. Some of you guys might already know what it is, but for those of you who don't, let's go to our calculator. So we're going to go to y equals, and here we're going to type in 27 divided by x. And then we're going to look at the table, so second graph. Alright, so as we go through this table, we want to see what is the biggest perfect square that goes into 27. And remember, we only want to look at the whole numbers. So since we are working with 27, by the way, notice I don't need to check anything above 25. It doesn't make sense. I know that everything below this will have to go into 27. So if I look at 1, 1 is a perfect square, but we want to find something bigger. So 1 and 27 gives us 27. 3 and 9. 3 is not a perfect square, but 9 is a perfect square. Because 9 is a perfect square, I'm going to write that in the first radical, and then write the 3 afterwards. I always like to write my perfect square first. You're going to see why. So square root of 9, when we simplify this down, it becomes 3. Radical 3 cannot be simplified anymore, so we're going to continue writing that down. As you can hear in the background, that's my birdie. You might see a video of her later on. Okay, so we get 3 radical 3. So we're going to do the same thing for square root of 50. So when we look at square root of 50, same process. We want to see what numbers go into square root of 50. I go to y equals, and instead of 27, I'm going to type in 50. Second graph. Now because we're working with square root of 50, now we only have to check 2 extra numbers, because 49 is less than 50, but we want to check all of these numbers to see which one goes into 50. As you can see here, we have 1 and 50, we have 2 and 25, 5 and 10, and then 10 and 5, it starts to repeat. So of these here, 25 is the perfect square, so I'm going to break this up into square roots of 25 times square roots of 5. Alright, so we're running out of space here. Square root of 25 is 5. And then, oops, made a mistake. It is not 5. I'm going to erase that. It's square root of 25 times 2. And you can see that from the calculator here, 25 times 2. So let's fix that. So this is square root of 2. So square root of 25 is 5. Square root of 2 cannot be simplified, so I'm just going to write that next to it. Radical 2. Alright, so this is what you learned yesterday, but we're going to use that for today's lesson. For today's lesson, we're going to solve by square rooting. Now, quadratic is an equation that contains x squared, as we've done from before. So, I'm going to fill that in here, x squared. And we can solve quadratic equations by square rooting. Now, this method is pretty easy, and it's a helpful one when you have a problem set up in a correct way. So, the opposite of square is square roots, and we can use this trick to get rid of squares. So, a quadratic equation can be solved in multiple ways. So far, we've learned how to factor, and today we're going to learn how to square roots. If a variable is easily isolated, then you should use a square rooting method. So what that means is that we only have one x, so it's going to be something like x squared equals 16. And this one's pretty easy to solve. Let's take a look at the first example. So the first example that we have is x squared plus 6 equals 13. Our first step says isolate the square. So this is what we want to get by itself. X squared, we want to get this alone. So in order to get this alone, I'm going to subtract 6 on both sides. Minus 6, minus 6. I cross that out. I have x squared equals 13 minus 6 is 7. Alright, now I want to get rid of that square root. So in order to, I want to get rid of this square. So in order to do that, I'm going to square root both sides. Whatever I do to one side of the equation, I do to the other. Alright, the square and the square root cancels out. I'm left with x, which is nice. Now square root of 7, let's see, can we even simplify that? So we're going to go to the calculator. I'm going to type in square root of 7. Now some of you guys know 7 is a prime number, so there's only 2 numbers that really goes into this. But let's just check. So I have 1 and 7. I look further and I have 7 and 1. So it can't be simplified because the only factors of 7 is 1 and 7. So I'm going to leave this as square root of 7. However, that's not my final answer. When we have the square root, whenever we take the square root on both sides, we need to make sure to include plus or minus. Okay? Remember, when we're solving a quadratic equation, we do have 2 separate answers. There's going to be a positive radical 7 and a negative radical 7. So you got to remember to include that plus or minus sign. That's my final answer, and that's it. Alright, let's try another problem. So for this one here, it's very interesting. We can't get rid of this 1 that's inside of the parentheses. We have to start to get rid of the square first. I'm going to rewrite my problem on the side here. We have y minus 1 squared equals 51. Alright, to solve this one, we got to get rid of this square here first. So in order to do that, change my color back. I need to take the square roots of both sides because opposite of square is square root. Square root here, square root here. That cancels, that cancels. We're left with y minus 1 equals, now remember we took the square root on this side. Because we did that, we need to include plus and minus square root 51. Now we're almost done, but the variable is not isolated just yet. So in order to isolate the variable, I need to get rid of this minus 1. We do the opposite, so we add 1 here, and we add 1 here. Now, I can't go inside of this radical. I can't just add into that. So what I need to do, I'm just going to write plus 1. And in order to write out my problem, I'm going to cross that out. We have y equals, since this can't be combined with that because it's trapped inside of this radical, I'm going to take this 1 and just write it on the outside here. So I have positive 1 or just 1 plus or minus radical 51. Alright? Easy enough, not too bad. Let's take a look at the next problem. Alright, so here we have to find the solutions of x plus 3 squared. Okay. So in order to find the solutions, we're going to do the same thing as before. We're going to have x plus 3 squared equals 12. If you would like to try this one on your own, pause the video and see if you get it right. I encourage you to try this on your own. Alright, in order to solve this, again we need to get rid of the square, so the opposite of square is square roots. I take the square roots of both sides. We have x plus 3 equals square roots of 12. Now, I made a mistake. Can you guys identify the mistake? Gotta make sure to have this plus or minus sign. Okay, so one thing that I didn't do in the last problem, and this is probably because I kind of knew the factors of 51, we got to make sure that whenever we have something under a radical, we got to make sure that it can't be simplified. And if it can be simplified, we need to simplify it. I'll show you what I mean in a moment. I'm going to subtract 3 here. Subtract 3. Again, that 12 is trapped under that radical. So I'm left with x equals negative 3 plus or minus the square roots of 12. Now, my mathematical brain, it's going off that radical 12, there is a perfect square that goes into that. So let's just check here. I type in 12 divided by x, second graph, and as you can see here, we have 1 and 12, 2 and 6, 3 and 4. 4 is a perfect square, and because it has a perfect square, I'm going to break this up. Now take a look at this. This becomes radical 4. Remember, I like to keep my perfect square first. Times radical 3. This one could be simplified down though. So this turns into 2 times radical 3. So this can just be written as 2 radical 3. Now remember, this minus 3 needs to come down, so draw my arrow. I'm going to write minus 3. Don't forget I have this plus or minus as well, so plus and minus. Now because this 2 is attached to this radical 3, I can't combine this negative 3 and 2. Can't do that. This is how my answer is going to look at the end. Oops. Uh-oh. There. So this is how it's going to look at the end. And that's it. Alright, next problem. So we got these two here. Again, you can take your time and work on these. Pause the video if you like. So I'm going to rewrite this problem. Choose a different color. 7x squared plus 1 equals 337. Okay. So first things first, I have to get x squared by itself. Now, to get x squared by itself, I need to get rid of this 7, and I need to get rid of this 1. So I'm going to subtract 1 on both sides first. That goes away. I'm left with 7x squared equals 337 minus 1 is 336. Next, I'm going to want to divide by 7. Divide this side by 7, and divide this side by 7. Now, I'm not sure what 336 divided by 7 is, so I'm going to use my calculator. I have x squared equals, and 336 divided by 7. When I press enter, I get 48. So x squared equals 48. Next step is that I gotta get rid of this square. As we know, opposite of square is square roots. So I take the square root of both sides. This and that cancels. I'm left with x equals, and I have square root of 48. Now remember, since we took the square roots, plus or minus, square root of 48. And that's our answer. Or is it? Remember, we have square root of 48. We got to check to see if some perfect square goes into this. Now, just by looking at these two numbers, I know that 4 goes into it, because 4 goes into 4, 4 goes into 8. Pretty nice. However, whenever we simplify, we want the biggest perfect square. So I'm going to split this up. And let's take a look at the calculator. We have y equals, and I'm going to type in 48 divided by x. I see 1 and 48, 2 and 24, 3 and 16. There's that 4, 4 and 12. However, the one before, 3 and 16, 16 is also a perfect square. Remember, 4 times 4 gives us 16. So I'm going to use these two instead. So I'm going to write my perfect square first, square root of 16 times the square root of 3. Square root of 16 is just 4 times radical 3. So I'm going to write this as 4 radical 3. And that's my answer. Just kidding. Notice we need to have that plus or minus. Now that's our answer. Alright, and we'll try one more problem. Oh, that's a beautiful line. Okay, so we have w plus 3 squared equals 26. Again, pause the video. You can try this one out on your own. It's very similar to the last couple that we did. So square roots, because there's a square first, everything's trapped inside the parentheses. I gotta take the square root first. Square roots. Cancels out, cancels out. We're left with w plus 3 equals the square roots of 26. Since we did the square root, we need to include the plus and minus. Now, again, we're going to try and see if anything goes into 26. So 26 divided by x. We have 1 and 26, 2 and 13, and nothing else. The next one that's going to go into it is 13 and 2. So I know that the factors of 26 is 1 and 26, 2 and 13. Because none of these are perfect squares, I can't simplify this radical. It's going to stay that way. So I'm going to continue, and I'm going to subtract 3 on both sides. We have w equals -3 plus or minus square roots of 26. And that's my final answer. Alright, so here's some problems for you to do. We have 2 problems. They look very similar to what we already did. And then there's a challenge problem. So what you're going to do on a separate sheet of paper, you're going to solve these problems and you're going to submit a picture of this on Google Classroom to show that you were looking at the video and you understood what we did. This is actually split up into 2 days, but because obviously we're not teaching in the classroom, I'm just going to move on with the next day's lesson. So as you can see here, we have 2 radicals again, and it's up to you. It's a Nuke Agenda, just like the last one. I want you to solve these two. Now, for the square root of 48, we did do a problem like that in a couple slides ago. So I'm just going to write the answer here. It's up to you guys to try and solve it. So we have 4 radical 3. And that's my answer for this one. And for this one, it would be 5 radical 6. I think that's right. One way you could check your answer too, by the way. Let's say you did all of the work and you got this answer here. You can check it in the calculator. So to do that, remember these two here, they have to be equivalent to each other. So if I type in square roots of 48, I don't really care what I get. Like I get 6.92. That's cool and all. But when I type in 4 radical 3, I should get the exact same answer. And when I type it in, clearly I do. So that means I did this one right. Let's see if I did radical 150 right. So square root of 150. And we're going to type in 5 radical 6. Yep, so I did that one right. And that's the one way you can check just to be sure. If it's a multiple choice question where you have to simplify, even easier. Just use your calculator. Okay, let's move on with today's lesson. So again, same type of problem. We're going to rewrite it. So we have c minus 4 squared equals 27. Now to solve for this one, same as before, we're going to take the square roots of both sides. Radical there, and radical there. We get c minus 4 equals radical 27. Again, since we're solving for a variable, we always have plus or minus. And now we just add 4 on both sides. Because we want c by itself, we add 4. We get c equals 4 plus or minus radical 27. Okay? So if we look at the steps, we isolated, we square rooted both sides. This is the last step here. We gotta simplify. So remember to try and simplify this. Radical 27. Now you can check with the calculator. I've shown you how to do that multiple times. But I know that radical 27, 9 goes into it, and 3 goes into it. So to simplify this, we get c equals, this 4 comes down, plus or minus. Radical 9 just simplifies down to 3, and radical 3 is radical 3. That's my final answer. Alright, moving on. So it says find the solutions. Same thing. Now this one's kind of nice. Take a look at what's going to happen here. I write q plus 3 squared, in parentheses, equals 64. Now again, everything's trapped inside of those parentheses there. So because of that, I have to take the square root first. Now something very interesting is going to happen. Cross that out, cross that out. I'm left with q plus 3 equals plus or minus the square roots of 64. Now some of you guys might be itching to do something right now, but don't do it just yet. Let's continue with the process. Subtract 3, subtract 3. We get q is equal to negative 3 plus or minus the square roots of 64. Now the reason why this should jump out at you is that the square root of 64, that's a perfect square. Perfect square of this is just 8. When we take the square root, it's going to be 8. So we're going to have 3, negative 3, plus or minus 8. Now we have two whole numbers here. We have negative 3 and we have 8. Whenever we have something like this, we have to simplify it further. Now remember I said before that this plus or minus means that we have 2 answers. Since we have 2 answers, we got to break this up. So I'm going to change my color, and we get 2 different answers. We have -3 plus 8, and -3 minus 8. -3 plus 8 is just 5. -3 minus 8 is 11. -11. We got 2 separate answers. Alright, so whenever you have a whole number, whenever the radical completely simplifies, you gotta make sure that you go through the full process. Technically, yeah, this is the answer. This is also the answer, but we always want it in simplest form. We want our lives to be simple. So we have q is equal to 5, and q is equal to -11. Alright, so definitely try this one on your own. Pause the video if you like. I'm going to continue solving here. 6x squared minus 4 equals 92. I want to get x by itself, so I'm going to add 4 to both sides. Plus 4, plus 4. 6x squared equals 96. Alright, now to get x by itself, I'm going to divide by 6, divide by 6, divide by 6. I'm left with x squared equals, not exactly sure what that is. I believe it's 16, but let's just check. 96 divided by 6. It is 16. Nice. Now I'm glad this problem came up because I want to talk a little bit more about why we have plus or minus. But for now, I'm going to take the square roots of both sides. Square root here, square root here. We have x equals, now square root of 16, that's a nice number. Again, 16 is a perfect square, so we just get 4. But again, since we took the square root of both sides, we need to have plus or minus 4. Now let's talk about why this plus or minus is there. I'll circle as my answer. They're saying that, hey, we have 2 answers here. If I have x squared equals 16, and I plug in both of these answers, do I get 16? Well, let's try it. We have 4 squared, and we want to know, does that equal 16? Now we kind of know that already, but let's just type it in. So parentheses, 4 squared, and indeed we get 16. So that one's right. So we get 16 equals 16. Cool. But what about -4? Now remember, whenever we plug something in, we need to use those parentheses. So I have -4 squared. Does that give me 16? Does that work? So in my calculator, I have parentheses, -4 squared. And would you look at that? We also get 16. So this equation here, x squared equals 16, has 2 solutions. This is why we always need to put plus or minus. Okay? So we do get 16 equals 16, and we're good. Alright, let's move on. So we have these 2 problems here. Again, pause the video so you can try and solve these. So our first step, after we rewrite, we want to get rid of that square that's there. So to get rid of the square, take the square roots. Cross those out, we're left with y minus 6 equals plus or minus the square roots of 81. Now we kind of know what that square root is, but let's keep on. Add 6, we get y equals 6 plus or minus the square root of 81. Now 81 is a perfect square, so I'm going to simplify that down. We get y equals 6 plus or minus 9. But since we have two whole numbers here, we got to split this up. So we have 6 plus 9, and we have 6 minus 9. 6 plus 9 is 15. And 6 minus 9 is negative 3. Now you might see your answers written in a couple of ways, especially if it's a multiple choice. 15 and 3. We can write this as y equals 15. We can write y equals negative 3. And that's one way to see our answer. We can also see it like this. So curly brackets, and I like to put my lower number first. So negative 3 comma 15. And curly brackets again. This is our solution set. It's saying that our solution for this problem is negative 3 and 15. So you can see these two ways. One other way that they really don't show very much is the solution set of y such that y equals negative 3 and y equals 15. Very rare that you would see that, but I'm just throwing that in there. Alright, let's move on back to the top. Now for this problem, this 5 is free. So since that's free, I'm going to subtract it out. Minus 5. We have v squared equals 73 minus 5. That should give you 68, I believe. Let me just double check. 73 minus 5. Yep, 68. And then we take the square root of both sides. Square root here, square root there. We're left with v equals, again, we did the square root, so plus or minus, square root of 68. Now, 68, that doesn't look like a perfect square, right? So what we're going to do is see if there's any perfect squares that goes into it. So I have 68 divided by x. Now let's see, we have 1 and 68, 2 and 34, there it is, 4 and 17. So if I continue looking, the next biggest perfect square, well, the next factor would be 17 and 4. So I know that I have all of my factors. My factors for 68 are 1 and 68, 2 and 34, and 4 and 17. Of all of these, though, 4 is the only perfect square there. So that's the biggest perfect square. I'm going to split this up. We have square roots of 4 times the square roots of 17. And only one of these can be simplified. The square root of 4 is 2. I have my radical, 17. Now don't forget this plus or minus sign. Plus or minus, so we have v equals plus or minus 2 radical 17. Alright. Now, we have 2 more problems here, and then a challenge. So your task for this lesson, you had 4 problems plus 2 challenge problems. We would like to see that you attempt all of these problems. Once you're done, take a picture of it, upload it to Google Classroom, and under the assignment that we assigned for you. Alright, that's all for me today. Hope you guys are enjoying this school at home, and I'll see you in the next video.